All right, happy Friday, A group, or anyone else who's at home watching this. I know we told you weren't gonna have to watch videos, but just with how short everything is right now till the end of the quarter, we thought it was best to just have you guys watch this one at home. This shouldn't be a long video, all right? I know it's 2 pages, but you can do this kind of quickly. So we're gonna be talking about piecewise functions today. Piecewise function is a function represented by a combination of equations. So it's not just one equation for the function, but there's multiple, right? And they start and stop at certain spots in the domain. So a piecewise function is going to be something that looks like this right here. So you can see that the function is this equation for the first half. Sorry about that. And it's the second equation for the second half. So if we want to graph, what a piecewise function looks like, all right, we want to graph 2x plus 1 for x is less than -1, all right? So I'm just going to graph 2x plus 1 actually. So there's our plus 1, right? And we know it's -1, so it's going to be on the left side. So I'm going to go down to, I'm going to work backwards. Down 2 over 1. And we know it's going to stop at -1. So it's going to stop right here, okay? So that's what our function looks like up until -1. And then it switches, all right, to 3x minus 4. Now, you need to pay attention to where the line is underneath in the symbol, okay? So I actually didn't do a good job here on the end. It does not include -1 in this function, right? So when it stops, let's get the partial eraser here. When it stops on this side, we want it to be an open dot, okay? Because we're not including -1 on that part of the function. We're including -1 with the 3x minus 4 part of the function. So we can go down, to -4. And it's 3x, so it's going to be down 3 over 1 back this way. So we do want a solid dot there. And then we can continue our function up, as far as we want. And that's it, okay? So this is what a piecewise function might look like, right? Piecewise, it's in pieces. So the line continues to a certain spot, then it stops and it picks up somewhere else, okay? So what we're mostly going to be doing with piecewise functions is evaluating them, which is like doing function notation, okay? So we want to use the same piecewise function to evaluate. So they're going to give us a function notation problem, right? F of -3. It's going to be important for you to figure out which of the two equations does -3 go into. And in order to figure that out, you're going to have to look at those domain restrictions, all right? So -3, is that less than -1 or greater than -1? Well, it's less than -1, right? So -3 is going to go into the top equation. So we can plug in -3, 2 times -3 is -6, plus 1, that's -5, all right? For B, all right, we have to look at the same thing. So f of 5, all right, f of 5 is greater than -1, so we're going to go into the bottom. 3 times 5 minus 4, that's 15 minus 4, so that gives us 11. C, f of 0. F of 0 is also greater than -1, so we're going to go into the second function there. So we got 3 times 0 minus 4. 0 minus 4, that's -4. So you can kind of see what we're doing here. This one's a fun one, all right? F of -1, all right? Which side does -1 go into? Well, again, it's the one with the line underneath the greater than or equal to, all right? Because that's the one that is including -1. So that one's going to also go into the bottom equation. 3 times -1, that's -3 minus 4, that would be -7. Now the last two are a little bit tricky, okay? Because the last two could be either, all right? Are you listening? It could be either equation. It could be both, neither, or just one of them. You have to check both, okay? Because this time it's telling us that 3 is an output. So that doesn't tell us what the x is. So we don't know the x could come from the top equation or it could come from the bottom equation. So what you have to do, all right, for the ones where they give you the output, you have to check both outputs, all right? And see, does either of them equal 3? Well, we know they're both going to equal 3, but will it work for this domain restriction? That's what we're going to find out. So we got 2x equals 2. So we've got x equals 1. So if the top equation was going to equal 3, it would be at x equals 1. So in order to find out if that's a solution, you have to ask yourself, does x equal 1 happen under this domain restriction? Well, no, right? 1 is not less than -1. So this graph on the left, right, it's eventually going to hit 3, but it never actually does, right? It stops short. So this is actually not an answer, okay? Now we can try the same thing over here. So we can add 4 onto both sides. That gives us 3x equals 7. Divide by 3, x equals 7/3. Does that work? Yes, okay, 7/3 is positive, which means it must be greater than -1. So that one is our answer, okay? So you always have to do that for both, because sometimes you could get 2 answers, all right? Like we're about to find out here. So when we try this one, when we plug, oh, sorry, we're not plugging it in. When we're setting our equation equal to -5, all right, we're going to solve. So we subtract 1, 2x equals -6, divide by 2, and x equals -3, okay? Is -3 less than -1? Yes, okay, yeah, so that is a solution, right? It fits in that domain restriction. We can do the same thing here. 3x minus 4 equals -5. We can add 4 to both sides. 3x equals -1, so x equals -1/3. Does that work? Okay. Is -1/3 greater than -1? Also yes, right? Also yes. So this time there's 2 answers that work for this, and that makes sense if you look at your graph and you look at -5, right? This is -5 right here. We do have 2 intersection points, right? Because this second line goes back down and goes back up again, so we end up hitting -5 twice. So that would be how you do function notation with a piecewise function. Now these ones, I want you guys to try on your own, okay? I want you to give them a shot, and then when you come back, I'll show you the answer. So go ahead and pause this video now and give these ones a shot. Okay. Hopefully you did that and you didn't just keep letting the video play. So if you're doing these, I'm just going to go through these real quick. All right, -5, that's going to be in the top one. -5 squared is 25 minus 1, that would be 24. -2, that would be included in the bottom one because of that greater than or equal to sign. So 5 times -2, that's -10, plus 3, that's -7. F of 7, that's definitely greater than -2, so that'll be in the bottom. So that'd be 5 times 7 plus 3, that'd be 38. Over here, okay, this one we've got 3 functions, but that's okay, all right? You just got to find which one matches which. So -2, Is -2 less than -4? No. Is it in between -4 and 1? Yes. So -2 is going to go into the middle one. -2, that's 2 minus 1, which is 1. 1, that'll be in the bottom, right, because it's greater than or equal to 1, so we know 1's going to be here. 1 squared is just 1. 2 times 1 is 2, plus 9, that's 11. G of -6, is -6 less than -4? Yes, so -6 will go into that top one. So you've got 1/2 times -6 plus 3. So 1/2 times -6, that's -3. -3 plus 3 is 0, so that one would be 0. So hopefully, wait, isn't this one 11? When I write 1. All right, hopefully you got these correctly. The last thing that we're going to do is use a piecewise graph. Okay, so function notation with a piecewise graph. Again, you're doing the exact same thing that we did for function notation with a graph, okay? You're going to whatever they tell you the input is, all right? And you're going to go up, all right, and find out where the output is. So f of -2, so we're going to go to -2 on the x-axis, look up, find that point, look over, it's at 4, all right? So f of -2 equals 4. F of 0, all right? F of 0 is right here. Well, it's actually going through the origin, so f of 0 would just be 0. F of 1, we go to 1, we look up, all right? Now, there's 2 dots up here, right? There's a dot here and here, but remember, we care about the solid dots. So we want to look here, so we look over, that's at 1, so f of 1 equals 1. F of 2, okay, we look up, all right? Again, there's 2 dots. We don't care about the open dot, right? We pass right through it. We want to go find the closed dot. That closed dot is at 3, so f of 2 is 3. So here's another one, all right? Let's do this one right here. So again, f of -2, all right? F of -2 is right here. The graph's on -2, so that equals 0. Now we're going to do some outputs. So when does f of x equal -2? So now we're looking at outputs, right? We want to see where does the function touch this line. Well, it touches the line over here, right? We look, find the input there, that's 5. 1, all right? When does this graph touch 1? All right, so we draw a line at 1. All right, and where does it touch? Well, it looks like it touches here, but it actually doesn't, right? Because that's an open dot, so we don't include that point. We're just going to include this point right here, and that's actually not -2. I don't even know what that is. All right, let's just guess and say -1.8, all right, is I guess where it looks like it could be because it's like right before -2. When does f of x equal 3? All right, draw a line at 3. So here it actually touches twice, right? It touches once down over here at -1, and it touches once here at 1. So this one will have 2 answers, all right? X equals -1 and x equals 1, okay? So hopefully this made sense to you, all right? All you had to do today was these notes. You don't need to do the practice, all right? You guys are going to do the practice in class on Monday, okay? So if you have any questions on this, make sure you bring them to class and ask them on Monday. That way you can get some help, all right, in the beginning of class, and then I'll let you guys work on the practice and we'll start reviewing. So thanks and have a great day.